This is Ashton Forbes. You are on Hard Truths number 5. Hard Truths is the podcast where we ask the hard questions and we get the hard truths. We seek scientific answers. We seek answers about things that are conspiracies out there, stuff that people do not feel comfortable hearing about. So thank you all for being with us. Roy D. Herbert, thank you very much. Theoretical physicist. He is also the proponent of dilation theory, which is a theory that seeks to understand the nature of space-time and what it means with respect to our lives. Roy D. Herbert, thank you very much, sir. Welcome.
Thank you, and good afternoon to you.
So let's just get right off to it. We have limited time, and I have a lot of stuff I want to ask you. So first of all, what is your job? What do you say? Well, how do you describe yourself to people on social media or people that you run across, et cetera, out there?
Theoretical physicist, essentially.
Yeah.
That's what I do. I think about problems within physics, come up with ideas to solve them.
And how'd you get interested in it?
Interested since I was a little boy, essentially, fascination with the cosmos and nature,
Yeah.
to a degree that I had an uncanny understanding of things. I used to keep my brothers awake at night, hypothesizing black holes when I was about 7 to 8 years old. Stupid things like that.
So who's
But
your
this is a long
favorite?
time ago.
Sorry to interrupt you. So who's your favorite physicist out there? Who do you look to for inspiration when it comes to physics and stuff like that?
My main mentor, I would say, would be Carl Sagan.
Carl Sagan. Yeah.
Yeah, from the past. But my current, I would call my chief officer at the moment possibly Cliff Burgess,
Oh yeah.
who's an extraordinary talented physicist and theoretical physicist. And we share a lot of musings on social media.
And what do you think? What inspires you about their understanding of physics, or what do you gravitates you towards them? I guess if we're going to use a physical physics concept.
I think well, Cliff is one hell of a guy,
Mhm.
so there's that. So it doesn't really matter about his ideas.
Yes.
He has a sort of open attitude towards things and towards people, and he responds.
Mhm.
So that's a bonus. People usually do not engage, that sort of level. But Cliff is one of those people who will engage with everybody. So
Yeah.
he's great.
Those are the kinds of people I like too, and that's the kind of person that I try to be as well. Somebody that doesn't judge people based on how many followers they have or whatever. Just tries to get out there and answer questions for people. It gets harder though, the more followers you get for sure.
Yeah,
Go
I
ahead.
try to answer as many questions as possible. I mean, some of them are quite silly, as you get.
Mhm.
Some are quite ludicrous, but the vast majority are very, very informed, and
Definitely.
even from people who have not been sat in the world of physics for all their lives or within any level of some sort of professional career
Yeah, and I
or
saw you
academic.
responding to people this morning as well. So thank you very much for your effort. And honestly, I was one of those people once upon a time. And look at us now. Now we're sitting here doing Hard Truths number 5 with you. So thank you again for being here.
You're
Um,
welcome.
let's just jump right into the physics. So can
Sure.
you explain dilation theory to us? I have it in my profile. I'm a big believer in it. I believe in the simplicity of it, but I want to hear it in your term, in your words. Feel free to take as much time as you want.
Okay, right. Well, dilation theory asks us to consider time, okay, differently. Okay, in looking at those weird and wonderful attributes of time, and asking ourselves essentially what's going on. Um, that's what I did, and that's why I come up with dilation theory. Um, Essentially, we should consider time, like all things within our cosmos, governed by the laws of conservation. Okay, when we do so, we find that time holds a fluidity in its continuous nature. Okay, goes back to a theorem called Noron's theorem, where things that have a continuous nature within the universe, in a linear motion or order way or any sort of fashion, will invoke conservational symmetry. We see this with liquid smoke, for example, where smoke is forced to share a direction and fall through an aperture, for example, which shares linear motion. And then it turns, conservational symmetry kicks in, and the smoke turns to a fluid. Well, time turns to a fluid, though we don't perceive the fluid side of time because we are what one could say abstractions within the flow of time. We only ever experience, one would consider, a now, a dynamic eternal moment, where the properties of any moment denote the particular outcome. That gives us a resolution to the paradoxical issue of the double slit experiment, for example, whereby the observer is simply an added property of any moment. Okay, they're either looking or they're not. Properties change. See, it's a dynamic. So essentially, symmetries and behavior within things are not, they don't break as such as what is the current thinking. They are dynamic in that they change according to your changes. Okay. So if we can consider those nows to be continuous, they invoke conservational symmetry. Therefore, time we can consider to be a fluid symmetry. So if we use some fluid dynamic analogies that we are more familiar with, we take our minds to, say, a stream. Okay. We look to the banks of the stream, the flow of the river there or the stream is slowed by the bank. If you were to throw sticks in by the bank, you would notice all the flotsam there around it is being gathered by that slowing of the flow, gathered to the banks. Okay, well, what's going on? Well, wherever we get slowing effects within relativistic fluid dynamics, we get a passive transversal inertia that is born that drags that flotsam to the shore, to the slowest relative speed of its flow. But if we look dead midstream in our flow of our stream, as it were, the fastest flow in the stream, there is no inertia. So in our analogies to time, as it were, the fastest relative flow will have 0g, is zero inertia state. Okay, and where time has almost stopped, as it were, it's very, very, very slow. We have very, very high inertia, and we see this with black holes. So if we use our analogy of our friends, for example, the phenomena, we see them whipping around very, very fast. One could consider that, and therefore having no inertia of gravity upon them, well, they're holding a relative faster rate of time than their surrounding. It's as simple as that.
Well, and so there's a couple things I want to ask on that. Then would that hold true as well to, let's say, like small objects, small creatures, beings like bugs and ants, and I think dragonflies as well? As would you consider that to be a similar phenomenon, just scaled down?
Exactly. If we take the analogies of the dragonfly, for example, it's a very much more simplified thing. It's very small. Therefore, its ultimate, the makeup of itself is much less complicated than me and you. So therefore, it will hold a much faster relative rate of time. We call its particular relative rate of time bullet time, okay, because we've done some things with them, and these things can dodge bullets, some species. So they can, they have a much faster relative rate of time.
Wow.
Let's put an analogy. If we were to look at, say, a wristwatch, for example, if we could, upon the dragonfly's wrist, we can give him one for a moment, imaginary. If we were to be able to view upon that wristwatch, it would have an incredible rate of time, be ticking away very, very fast. But to him, the dragonfly, it's normal tick-tock seconds. You see what I mean? It's the
it's all frame of reference, right?
Yes, things can hold different relative rates of time. Now, one of those funny things is, and we just had a result, pushed it in yesterday, was with the neutron star side data that's just come in from the LIGO results. One of those little quirks that come up previously before that, a week before that, was the correlation of the spin rate of neutron stars to the spin rate of certain forms of quanta, in that they correlate precisely. Now, so how is that working? Well, neutron stars essentially hold an extended electron cloud, and therefore hold the properties of quanta, and are therefore given the phase of quanta.
Yeah.
Hello?
Yeah, sorry, I'm listening. I was just, can you see the screen right now? I'm not sure. I shared because I think, is this the example you were talking about from yesterday?
Yes. Sorry,
quark
actually,
matter
that threw
course.
me. Myself disappearing threw me.
It probably confused you for a second.
Yeah, so what we've discovered here is that essentially a neutron star is a supersized atom. Okay, so, what's going on? Well, basically what's going on is the material has been compressed down to such a degree that the electrons within the actual material of the actual neutron star can't sit there. Okay, they get extended, and by having that extended electron cloud, essentially emulates the properties of quanta. Therefore, the universe considers our neutron star, even though it's the size of a neutron star, quanta. So things essentially can be considered quanta if they hold the properties of quanta, no matter what their scale. I call this thing dynamic behaviorism, in that properties denote the behavioral outcome independently of scale.
Yeah, so with respect to neutron star, then are you saying that the neutron star can teleport, move at the speed of light, or what kind of properties are we going to be able to see from an object like a neutron star that appears to achieve the properties of quanta? And here we're talking about like just the pressure is causing the atoms and or the neutrons and the protons to, I don't know, maybe even coalesce into this quark matter, I think is how it was described, which then allows the whole object to act like an atom. You know, what kind of things can we see from that that can prove that to us, to prove this unification of very large objects to small objects?
Well, we can test that spin rate, for example, and that correlation to that quantum rate is sigma. Okay, we can look at the actual makeup of the neutron star, and as we can see from the makeup of that pictures that you provided, that it checks out. Okay, so we can see all these different bits and pieces. Basically, what we're looking at is we're looking at the behavior of the thing, okay, and the powers and the scales and the energies that are coming off of it. And if we take those and we take them, reduce them down to the quantum scale, they correlate precisely. Okay, so we can pretty much firmly guess, okay, that's definitely considered an atom, okay, by the universe. So, which provides some issues in that things can hoodwink the universe essentially into considering them at the micro scale, and with it, the package that comes with it. Now, when you're at that scale, as such, or considered that scale, you no longer interact with the larger scale in the same way. And there's a set of different rules that apply to you, as you pointed out, the rules of quanta. Okay, so certain things can hold superposition. We can imagine a black hole to be a neutron star in superposition, not holding a physical state at all at that particular time, because of its underlying quantum information cannot come to determination of precisely what is there. So, in other words, the black hole is where a neutron star can no longer be rendered within our universe.
That's really interesting because it seems like that would be the ultimate conclusion of the quark matter situation, right? Where you get so much pressure, so much gravitational force there that it, you know, now causes us to have this. You could even call it a non-radiating barrier, but you see essentially the shell of the black hole, you know, the event horizon, right, where we can't see anything past that anymore. So it does seem like it could be possible that a black hole is simply a neutron star, and I think physics would say that it is potentially just a more dense, more massive object, one that causes that potential phase transition to happen at even a larger state. So I think that that's the beauty, I think, of, in my mind, the physics that you've put forth is that it provides a underlying symmetry, or I guess, for lack of a better term, unification of things that are very small versus things that are very large. So you would
Yes.
go ahead.
Someone sent me a tweet the other week, actually, as above, so below.
Yeah.
And it is the case. It is a geometric unity, essentially. And that geometric unity is achieved through conservation of symmetry.
Do you know where that statement comes from? As above, so below. I've heard that a lot of times. Curious, is that a biblical quote?
I have no idea. Someone sent it to me, and then a colleague told me, "Oh, don't let them take you down there, for God's sake." And I said, "Okay."
Maybe someone in the chat can tell us. Yeah. The other thing I just want to quickly back up again on is when you were talking about the double slit experiment in time. I think that's very interesting to me in terms of like the way we perceive time is through our own initial frame of reference, because now you can still adhere to laws of physics, but now you can have things like non-locality and quantum entanglement exist, where it's like there's an underlying framework that we can't see because of our biology, because of our frame of reference, that can allow things to move faster.
locked in the box.
Yes, exactly. Yeah,
Yes.
locked in the box is a good way to put it, right?
Hmm.
And there's a meme that's been going around recently that I really like a lot, where it's the guy that like looks to the side and looks straight ahead. And when he's looking to the side, you got the wave pattern. And then when he's looking straight ahead, then it breaks down to the double slits, right? Um, and so, yeah, I think that your idea and understanding of or dilation theory seems to make a lot of sense to me. And just to reiterate, and you can jump in here, for a lot of people who don't understand, time dilation is a real concept, right? So what we're talking about
Yes.
with frames of reference is it's already been proven for 50
Oh,
years or more, right? Go
yes.
ahead.
Long time, long time.
Yeah.
It's nothing new. This is what it is. I'm not suggesting anything new. I'm just asking that certain principles that we have adopted over the last 80 years, that being conservation, should be applied to time.
Yeah.
And that time can be described as an entropic emergent phenomena, essentially, that comes from all things within the cosmos, even if they hold no physicality at all. There's still some determination of what's going on. So therefore, there is some form of change, and therefore time. You see what I mean?
Yeah.
So where we
Okay.
have nothing in the universe, for example, nothing at all, then we get expansion of the universe. And where we have that slowing of time at all, we have a compressioning of the
Hmm.
universe, essentially. So these two things are, you see what I mean?
Do you think that explains dark energy? I mean,
Well,
we're skipping ahead, but
yes, one could consider dark energy to be essentially the canvas of our reality.
mm,
Okay, it's bubbling up as a almost like a default, as it were, a default determination, a null determination, as it were. Um, it's quite difficult to get your head around. But if we look at dark matter, for example, if we now, okay, the problem with dark matter is that we cannot equate for certain forces of gravity that we see within galaxies, okay, according to the amount of mass that's there. So that's why we call it dark. There's something there that we can't touch, we can't see, but it's causing this gravity. Well, the big problem was that they never knew actually what was the cause of gravity.
mhm.
But if we actually narrow that down now and say, okay, if we put it into an abstract form, let's say, okay, here's my abstract. Complexities of quantum information determination denote one's dilation, and dilation stress on that fluid symmetry of emergent time denotes gravity. Okay, so the dilation stress, the slowing of time, powers the inertia of gravity. So what is that dark matter? Well, essentially, that dark matter is now an unqualified form of dilation.
Mm.
So what we should be looking for is something that's slowing time. What possibly could be slowing time? Well, let's take, for example, the start of a galaxy in its life cycle. It's a hydrogen cloud, a nebulae. Okay. Let's take its particular dilation and rate of time. We know that particular dilation rate of time of particular quanta is like our neutron star, very, very fast. Okay. Needs to get slowed down, as it were, so that gravity starts to take effect. We need some dilation. Okay. More complex forms of energies are created in this stellar evolutionary process. That matter, that's still that hydrogen, same stuff, but it's now transformed. Okay. It's transformed into more and more and more and more complex forms of matter. Is that galaxy's dilation rate going to be exactly the same as that nebulae cloud, even though it's exactly the same mass? No, of course it's not. The complexities of the determination denote the dilation. Okay, so things are getting more and more complex. They're taking longer and longer and longer to determine in time. Okay, that gives you your missing factor. Also, a galaxy should come to, at some point, life. Okay, will it happen? A galaxy's audience could also be that missing factor of unqualified dilation.
So you would
There's
say
lots
that,
of unknowns. You see what I mean? So
yeah,
once we
complexity increases.
start
Go
to
ahead.
look at, once we start to look at gravity and time and its relationship between that and energies, okay, and knowing fully, resolving that issue, then it resolves not just gravity, but all of the issues. And it really lays it out in a much more common sense way. You can perceive things. You don't need a degree. you don't need a PhD. You just need common sense.
Yeah, and I was watching a presentation, which I want to get into with you in a few minutes, but it pointed out that if you were to just take from a quantum level to try to understand and graph how information gets more complex, you could look at it like a string where the string is getting longer, 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 and longer, and longer. And then the idea there is somewhat the same, which is as things get more complex, the string just keeps getting longer, keeps growing. And that could be, you could analogize that to the inertia, right? You're getting more and more
Yes,
inertia, which is slowing things down, which is making things more
that's right.
complex. So that's why one of the
More
questions I wanted to
inertia.
ask you is, what do you think dark matter is? But I think you just went ahead and answered it for us. Is,
Yes, I did.
complexity is the answer, right? Is that you think that's a growth of complexity of whatever mass you have in space time, right?
Well,
Is that summing it up?
it points to, it goes back again to the double slit in that it points to the universe being stochastic and deterministic rather than probabilistic. Okay, that's what it means. It means that there's something else going on under the hood, a process whereby a determination, it's passed beyond the paradigm, as it were, of emergence, then is returned. And according to how long that took to return, that denotes one's dilation. Okay, so I call this underlying modus operandi dynamic behaviorism. Okay, in that basically essentially is all defined in eternal dynamic moment, that now. Okay, and your properties denote the particular outcome for you. Okay,
Yeah.
and that ultimately is a form of conservation as well, in that it denotes what conservational symmetries should be applied to you in time. So this thing can look backwards and forwards in time to determine what it should do for the now to give a more conserved outcome, perhaps even in the future.
Yeah, that is
So
explained
this
in
thing,
double
yes.
slit
So
experiment,
this
right?
thing happens outside of our emergent time.
Yeah.
So in other words, there are more layers of emergent time that we have yet to discover. Aha, there you go.
Oh, that's great. I love that. I wish I had a snow globe right now because I always think of it like the snow globe scenario where it's like you can shake the snow globe, you can watch it go, but that's not our time on the outside, right? It's something else like a mini universe that's going on there. And to me, what you're saying means that I'm just going to call it the matrix. I just love the idea of the matrix, right? There's an underlying matrix in which our reality is being projected onto, right? Because that's the only way you can explain how you have this capability to look backwards and forward in time. Would you kind of agree that this must imply some sort of construct to our universe?
Yes, the double slit experiment itself, as I've been saying, that form of dynamic behaviorism points to if you are a software developer, um, you're painting an area of a screen, you need to determine what's there by the properties of what the viewer is looking at.
Mm-hmm.
Properties denote the outcome.
Got it.
It's a holographic paint event. The now is a holographic paint event, and it
Yeah.
is dynamic. And I'm not sure if it can be overloaded.
Hmm. When you say
Okay,
overloaded, what do you mean in terms of
more parameters,
adding more parameters?
perhaps.
Interesting. Yeah, it does make
Okay.
me wonder if you could hack into the underlying code, right? If you think of it from like a computer
Well,
program standpoint.
a neutron star's doing just that, and so are our friends.
Yeah. And we're going to talk about that in a minute as well. Before we get to that, though, I want to stick with a little bit more scientific stuff as well. So one thing I want to ask you is, do you believe in string theory? So one thing you mentioned is, I hadn't actually heard this that you mentioned in terms of like, I like to think of it as the universe is able to look backwards and forwards and figure out what it should do, right? And that's definitely what we're seeing in the double slit experiment. So
Yeah.
do you think this
That,
supports the idea of string theory, or what's your idea, your concept or understanding of string theory?
string theory fits in there. Okay, I'm not going to destroy every swampy's dream.
Yeah.
Okay, which is a nickname we give for people who work in string theory for people who don't. It's not an insult. Okay.
Yeah.
But basically, yeah, string theory fits in there somewhere in that determination has to change what's there. Okay. So even when that determination done, the universe has to perform that actual action of saying, okay, draw you, render you as so. Now that, yeah, string theory comes in.
Hmm.
So one could say that that's the communication medium between the dynamic behavior and modus operandi and the fabric of reality itself, abstract.
Hmm.
Okay.
But what
So
about
that's
breaking?
where the,
Oh, go ahead.
yeah,
Keep going.
so that's where the fields come in essentially.
Yeah.
The fields are that manipulation process at work. Okay. But my stuff is more of what's going on behind the hood, as it were, under the hood, and projecting that, as it were, understanding gravity more, and this geometric unity
Mhm.
that's obviously there. I mean, to be honest with you, I'll be totally honest with you. I don't want to be egotistical, but all this is pretty much child's play for me.
Yeah.
I've been doing this for since 1997. I actually put the first thing together. So I've been shouting at doors for years and years and years and years, and every single result that comes out, Ashton, it's like bang more sigma, and they're still going, no, we're not listening, we're still hunting for this over here, and dark matter, and no, we're sure gravity is like this, and they're still going fail, and
Yeah.
but it really is. It's a lot of it's really basic stuff, basic relativistic fluid dynamics and laws of conservation. And yeah, it's just ignored. It's just stupid. Sorry, it is.
Yeah, no, I think we can talk about that for a second too, because I was just posting yesterday, and I was digging into this investigation, and I found this guy Matthias Chang, and I found this quote from this interview he did, which was really good, where he says that people were asking him, "What do you think happened? What do you think is going to happen with regards to this plane investigation?" And he says, "Well, people are so brainwashed and conditioned by what they get told, and people that are the authority that they're willing to believe just at face value." Whatever someone says in terms of they give them a story from the authority, people believe it. And that's what I've come to realize. And I think that stuff like you mentioned threatens the paradigm. But isn't that what science has always been? Science is not a process of gradual improvement. What it is people break through the barrier, right? And they set a new paradigm and then people adjust. That's been
Yeah.
my view. I don't know what your thought is.
Um, it's been going on since Galileo, Copernicus, Einstein, you name it, Newton, Darwin, you name every single breakthrough in human understanding has been kicked and pushed into the gutter, and the person's been kicked and pushed into the gutter as well. So that sort of stuff, because there is an orthodoxy, as it were, and that is entrenched with its own interest. Now, if I mean, I know I'm right. Okay, I'm not alone anymore. I've got one of the world's leading mathematicians to go through this in the last 2 years and go, look, shit, you're right. And he's done all the math and the equations and everything else. And you can probably see by the amount of world's leading physicists that now follow me,
Yeah.
that they smell something's right.
Blood in the water,
And
as they'd say. Something's
yes,
it's
yeah,
feeding time.
exactly. Well, I say to them, don't bloody argue, because
Yeah.
I'm using their argument against them, because we present the invariance and all the data and everything to them. And we say, don't argue, calculate, and just go with the flow, baby.
Yeah, that's good given the analogy of the stream. I like it. Um, I want to go back real quick to the dark energy stuff because I think that's really interesting. That's something I had never considered as well, which is that, the way that conventional academia explains the universe says that there's this big bang, which let's just go with it for now. I'm not sure I 100% agree, but the thing about it is that they say that the universe would have had to expand faster than the speed of light, right? And this also kind of comes into play when we start talking about quantum teleportation, right? And talk about superluminal speeds. Well, if you think of the underlying matrix with nothing projected on it, there you have exactly zero inertia, right? So now you are going to have superluminal speeds are now possible, right? And now that could explain dark energy, how you get this expansion of the universe faster than the speed of light. So that's a new thing that I've just kind of epiphanized on based on our conversation just now. So do you have any comments on that?
Yes. How many systems, you're a programmer and developer, how many systems have you mounted and started an instance of
A
and
lot.
watched its memory and CPU on?
Yeah, quite a
Now,
lot. I've been on a
right,
lot
well,
of sites across the country. Go ahead.
go and mount something very, very juicy and then kick it into run. But
Mhm.
as you're mounting it, look at the actual pressures and the loads on the CPU and all the memory and all the heat and the temperature that's being kicked out by your system. Measure it all. in graphs,
Mhm.
and then align that graph to the expansions and the other bits that were happening within our universe, and one will find a correlation.
Hmm. That's a good idea. I didn't even really think about that, but yeah, I mean, it's
Mm.
in things of like, yeah, bringing on a new computer system, watching the power use increase over time, get more and more complex. You could say that there's this pretty strong analogy to what, our universe is. And even the fact that we even have computers and you can describe everything in ones and zeros almost makes me wonder, is that already us hacking into the underlying framework of what our matrix reality really is? So
Who
good
knows? Who
thoughts.
knows? Well, we know that if we take my theory and we say that time is an emergent entropic phenomena, then it's emerging from somewhere. Okay.
Yeah.
Now, my ideas are that it emerges from what we would use in analogies within the development world as parental domain, for example. So that parental domain, our emergent contextual duality emerges of. Okay. We could call that parental domain the domain of quantum information. Okay. But ultimately, I believe there's a methodology at work, i.e., that dynamic behaviorism, that underlying modus operandi says to me, I am a behavioral governed methodology.
Hmm. So
Okay. The similarities are just far too strong. Okay. So one could look at that. One could also use the analogies of a virtual abstract terminologies when looking at our duality, for example,
hmm.
our virtual side of magnetism and so on, and the abstract side, electricity. So in that duality, as it were, we are, for example, abstract.
That's interesting.
Okay.
Dave Rossi was just talking about the duality of magnetism and electricity yesterday on our space,
Well, there
and,
you
and
go.
giving an analogy of the
So
male and the female. One thing I want to ask
yeah,
real quick on, would you say, am I defining dynamic behaviorism correctly when I would say that it's essentially going back to the double slit experiment, how the universe is able to look backwards and forwards and determine what should happen? Would that be a good way of describing it?
yes, it is the underlying modus operandi of our abstract reality. It governs conservation, which is everything essentially, even time, light, absolutely everything within the universe is governed by conservation, even this dynamic behaviorism. So conservation comes from a higher contextuality.
Hmm.
See what I mean, Ashton?
Yeah.
It has parentality, it has precedence as such in the order,
Yeah.
as
It's
it were.
like,
So it's coming from much higher.
it's like if you
Okay,
have
so
a hierarchy of rules, right? And it's like, okay, that's the
yes,
hierarchy, the
yes,
top hierarchy of
you
the
got it.
rules system, right?
It's you got it. It's the top constraint.
Hmm. Interesting.
So one, yeah, and therefore one could it basically envisage therefore that and I think who was it? Incredibly, Gerald T. Hooft put out a publication a year ago after I went public, proposing almost exactly the same, in that the laws of physics are essentially an inheritance of those constraints, as it were, up the scales. Okay, so yeah, we can answer all the problems of where all the laws are coming from, how that's all coming through, and so on, and all those bits and pieces. But it's like going back to the point you were making. What was the point you were making about? Remind me if you can. I always
Uh,
do this.
no, I think that was pretty much it. It was just the idea of this construct and then these rules that we have on top of it and understanding what dynamic
Yes, the
behaviorism.
parental domain. I was
Yeah.
talking about the parental contextual domain. Yeah.
So,
Now, is that the ultimate contextuality? Perhaps not.
mm,
Where does it stop? I don't know. Um, so if we think about the three dimensions,
mm,
and then we talk about the dimension of the gauge of time, we've
mm,
got four dimensions.
mm,
Anything else from that, we shouldn't really be looking at it as dimensional.
yeah,
We should be looking at it as contextual,
I
okay,
like
as
that.
a form of contextuality. Okay, so we exist in, as we know already, we exist in a few different contextualities. You're abstract, I'm abstract. Okay. There's also a fluid quantum side to us. We know that we exist as well as quanta.
Hmm.
Okay. We know what those properties are now. We understand it all about that, that very cold thing. But that's part of you, and it's not harming you, is it?
Oh.
So We have much to learn about this other side to our contextuality. Okay, that other side of that contextuality to us doesn't hold a physicality.
I like that understanding because I've always struggled with this idea of like 5, 6, 7, 8, 9, 10 dimensions, right? I think it needs to be simplified down where it's like, okay, we've got the
No,
three dimensions that we see, our three axis, right? I can explain this, right? Three axes. And then you've got the fourth one, which we can understand as time because we understand time dilation is a real thing, right? And we understand frames of reference. But beyond that, I like the idea that the rest of it's contextual, right? It's
yes,
like trying to understand how we all relate to one another. Doesn't mean there's necessarily another dimension that's there. It just means that
no,
there's more properties or more underlying behaviors that we don't quite understand related to the dimensions that we do experience.
it's just different forms of contextuality of the same thing.
Hmm.
That's where you have the geometric unit, and it's that conservational nature of the universe that's providing all that for us.
And
You
if I
see
could,
what I mean?
yeah. If I could opine just for a second too, I think that my mind's already starting to get blown from this, but I am starting to think that there's a relationship between engineering and physics itself, where you need to understand the rules, right? The dynamic behaviorism, the upper bounds of what those rules are, and the hierarchy of them, in order for engineering to be able to know how to produce the effects that you want to be able to create. Right. And
Correct.
once you have that relationship, then once they kind of mesh, now you can, I would say, perform magic essentially.
Earl Grey hot, please.
And I don't know if we're talking about Star Trek replicators, but why
Why
not?
not?
Honestly, why not at this
If
point?
you can manipulate matter to that degree, and you can actually manipulate the quantum information side of the contextuality, we could potentially say, "Oh, don't render me here, render me there."
Mm. And that's
We could
what we've
say,
been seeing happen with quantum teleportation. They just teleported a picture, a full picture was teleported, I think, just last week, where I
"There
think
you
it's
go."
amazing that science is starting to catch up with, us, you, and and the
Finally,
investigation that we've been putting in. Yeah, and like
well,
you said, it's been 30 years, right? And
yeah, yeah, 1997, nearly 30 years. I think.
yeah,
Yeah,
25, 30 years. And every
yeah,
day I think that we get more and more evidence that begins to show that no, these types of concepts aren't just, crazy theories. They're just stuff that
no,
actually explains reality better than conventional understanding, right?
yes, it really does, and it does so very, very simply, and one doesn't require a degree, just common sense.
Yeah.
Okay, that's all you
Um,
require.
so the next thing I want to kind of want to go to, which is similar to what we've been talking about, is are you familiar with Susskind and Maldacena by any chance? ER equals EPR. Um,
No,
okay,
no, I
well,
don't.
I'm
See
going to
what I
get you up
mean?
to
This is
speed then.
this is Newtonian physics essentially, and
It
string
is.
theories and field, the field theories and so on. But
So,
most of it's
okay.
been washed away.
So here's what their theories are. They've had this theory called ER equals EPR. And what it essentially means is general relativity is equal to quantum mechanics. And actually, before I get to this, I just want to ask you a pretty simple question, and you can answer however you want. Is do you think that we already have unification theories of quantum and macro?
Yes,
Or
we
if,
do.
yeah, and would you say that your theory of time of dilation theory is one of those theories, or if not, what would you consider to be one of those theories that unifies quantum and macro to be?
Um, Dynamic behaviorism is the unifier. Dilation theory is the explains the cosmos of what we see and gravity and the structure of the larger scale, whereas dynamic behaviorism covers the other side of the veil, across the paradigm, as it were. So you have to put them together to unify the cosmos. One has to answer all phenomena in the universe, not just that what we know and understand now.
Yeah. Okay. So, it sounds like
So
yes. You're
yes,
saying you're saying yes.
but
And so, just to reiterate and just to correct,
it
oh, go ahead.
requires two sides to the coin, as it were, to be solved rather than just the one.
Yeah, and
So
then
and
go ahead.
yeah,
Yeah. And so that's where the ER equals EPR is. And just to correct something I said before, is that I don't think we would describe as Newtonian physics. It's more of Einstein, Rosen physics. Now, ER is Einstein, Rosen. And what we're talking about there is wormholes, like a
yes,
bridge in general relativity. Some people have argued that black holes might have either another black hole on the other side or white hole, however you want to think of it. But you can think of a underlying bridge in the matrix, right, where you can break through and take a shortcut, right? It's like you find a little
Yeah,
shortcut. And then
yeah,
EPR is Einstein-Podolsky Rosen, which is quantum entanglement, spooky action
yeah,
at a distance, right? And so what Susskind and Maldacena have argued is, well, these concepts are fundamentally related. Now, quantum entanglement, what you're talking about, dynamic behaviorism, right, is it's taking a shortcut. It's finding that underlying way through the matrix, same way as the wormhole analogy is. And so what they argue is that there is no difference between the two. It's really just a matter of perspective and size, similar to what you would argue with respect to your properties that are out there. Um,
yes,
and so when we already have stuff like we have quantum entanglement, we have quantum teleportation, they're literally teleporting pictures, right? It makes me wonder if perhaps it's just a matter of our perspective, is that we're not going to see a wormhole like when we look out there, right? We're just going to see maybe even just the mouth of it, maybe even not that much. And it's not like it has to be something that's sitting out there. It's not, since I can tell you like Star Trek Deep Space Nine, where this big wormhole thing appears and you're looking inside of it, right? That's not really what's going to end up happening, right? Because when we look at quantum teleportation, it's not something where like we can see through the whole of where this information is teleporting. It's just that there's this
no,
underlying framework that we can't see, right? That's
that's right.
able to do that. Now, what are your thoughts in general about that theory
Okay,
and that unification?
sure. Okay, well, as I expressed, the unification comes from the geometric conservational symmetries. Okay, so that explains all the unifying of the scales. Okay,
Mhm.
in that basically the rule of that, it's basically a new law, the first law. Okay, in that our properties denote our behavioral outcome. Those behaviors are the states of matter, for example.
Mhm.
Okay, like the Bose-Einstein condensate. That's one of those base states of matter. Water as a fluid is, as a gas is, as ice is, and so on. So these are not things that we don't understand, we don't know about. It's just that we different terminologies. Okay. Now, wormholes. Um, yes, potentially. Okay, as I said, if you can manipulate the contextual domain of quantum information, but it's not in the same way, you see, because this is where they got all relativity wrong, Ashton. Okay, in that underlying thing of the energy tensor is it's right, okay, but there's more to it, as it were, in that the more entropy energy one has, the more dilation one has. Okay,
Mhm.
so it's the dilation that's causing the inertia,
Mhm.
the slowing of time. So it's time is the big factor, not light, not the mass, okay, but the time. Okay,
Mhm.
so if we and those and going back to the wormhole thing, okay, because we've corrected all of that misunderstanding, majority of what they're saying no longer applies.
Mhm. So here's
Okay,
an interesting
we
thought
have
on that,
to,
real quick.
yeah, we have to rethink the whole scenario. So let's think of it in that contextuality
Yeah.
way. Can we achieve it? Okay, can we go from point to point within the universe? If you could, for example, amend your quantum information to say, I'm not where I am, but I am somewhere else, and I need to look after the consequences of the void that I leave behind me and all relevant impacting information, and do exactly the same the other side, the other end, and I can do all that in that now, then no problem.
Mhm.
But I doubt that will ever be the case.
Well, so it's funny because that's what Susskind and Maldacena actually argue, and it's interesting when you watch their presentations about it, because the one limitation that seems to hold back macro scale teleportation through a wormhole is mass, and they say
Yes,
that you would need the mass
entropy.
because the mass is like I say it's like your butt trying to get through the doorway, and you can't
You
quite
got
fit
it.
through, right? So we can
Yes.
see it works on the quantum level, but if we reduce the mass to zero, then the equations seem to work out, where now you can have a macro scale
Now,
object,
now,
right?
yes, now we're
And that's I
coming to
think,
it.
yeah. Now that I think is what's
Yes.
that allowed those unification. And then at that point, you're just saying I'm just allowing quantum teleportation of a macro object because I reduce the mass to allow it to obtain the properties of quantum, right?
You got it. So yes. So potentially not
Hmm.
as our form as we are in this, but in that potential state, as it were, holding that zero, quantum-like state, okay, phase, potentially yes,
Hmm.
very much
Interesting.
so, using entanglements. that sort of thing, or where we are. But we've got to make sure that the outcomes are more heavily weighted, that we're over there rather than where we were.
Yeah.
You see what I mean? It's like that. It's that deterministic process needs to be ticked, and the conservational rule needs to be ticked. If it's more conserved to do it this way than the other, the universe might say, all right, fine.
Yeah. Well, so I want you to hear this part then too, because this is really weird. I'm gonna have to send you these presentations later. Because the one part that I was trying to get my head around is they throw someone into the wormhole and then they take a measurement on the side where they threw somebody into the wormhole. And this closes off that side of the wormhole. Then they throw the information over to the other side. You can think of it as phoning somebody on the other side. And when the other side looks at that information, that shoots the person out from that side of the wormhole. And I've been trying to wrap my brain around that. But it's almost like what you just mentioned in terms of like this level of symmetry where you have to say you have to close the gap on whatever happened on the one side and now allow them to reappear on the other side without, breaking causality or what have you. I still haven't really fully grasped it, but I think there's something there.
Yeah, I don't think so, mate. Honestly, I don't think it will ever, ever, ever be possible. And we don't particularly need it to be possible because we have alternatives. Okay. Let's take that in zero inertia state.
Yeah.
You are now, let's close our minds, open our minds a bit and say, okay, we're now considered quanta. We have a much, much faster relative rate of time. We don't hold any physicality as such anymore. What else? We're very, very cold. What other attributes would we have? Okay, we'd have a zero inertia state. So the geodesics essentially of the lattice of space-time are no longer applicable to us of the larger scales. We now follow the rules of quanta. Okay. Now, as quanta, with that is zero inertia state. If, for example, we know now that any form of entropy, i.e. slowing of time, okay, creates that inertia, that passive transfers to the inertia of gravity. So we can now use that for our benefit. We hold a zero inertia state. Any directed entropy in any particular direction will create that inertia and tug us through the universe. But pulling the universe towards us, essentially, we do not move. We hold no motion at all.
Yeah, okay. So keep going.
We know that black holes essentially light cannot escape them. Why? Because the black hole is essentially consuming the universe, the cosmos, as it were, faster than the speed of light can travel through it. Okay, so this method of modus is essentially there is no speed limit.
Yeah,
and we can speed time up enormously. Okay, so speed, time, and distance. Time is a variable of that equation. You speed up the time, as it were, you shorten your journey massively. Okay, so yeah, it's that sort of stuff. So we don't need wormholes.
Yeah,
we can already go anywhere at any rate of speed.
And so how do we
without motion?
Oh, yeah. And so, yeah, that's the part too I'm trying to understand with but without motion part. Because so what would your thoughts be on the Alcubierre drive, right? Where the Alcubierre drive says, yeah,
absolute winning idea.
So I'll just do a quick explanation for people who may not be familiar. But Alcubierre drive is essentially the concept behind Star Trek warp travel. And the big issue when moving at very high speeds is that you have friction, you have this capability where the people inside are going to get liquefied essentially from the kind of the effects of moving at a very high speed. So what you need is a bubble around the object in space-time, which can allow, therefore, be a different frame of reference on the inside versus outside. And once you achieve that, it sounds like we achieve kind of what you were talking about, where we can have zero mass, and now this object can move at warp speed, if we want to call it, whatever speed you want. So what are your thoughts on that? How do you think we would achieve this Alcubierre bubble in order to allow for this zero mass and therefore increase local speed, essentially, that you're talking about?
Well, that zero inertia state, that mass reduction trick, essentially by the manipulation of time, essentially, and one's relative rate of time, produces that mass reduction effect. So, like I was saying, we can use that to our advantage as well, in that we can create directed entropy to, shrink space-time essentially in front of us. So we're shrinking. You see what I mean? We're not actually moving. We're manipulating the lattice essentially. Okay, so we're doing that. That's achieving that particular aspect of that puzzle. Jacobi drive, it is the same thing essentially. That entropy is slowing time, and that's why he's speeding up time at the other end of him. So he's getting double the whack, as it were, a pull and a push. You see what I mean?
Yeah, so you would say you would be contracting space-time in front of you and expanding it behind you. Is that what your understanding would be?
Yes, exactly that. Yeah.
Interesting.
That's all you need to do. Okay.
Yeah, I think it's
basically, if you have, say we had like an egg or anything else, if we were to just have an egg in free space, okay, if one side of our egg had a slower relative rate of time than the other side of our egg, it would potentially for its own motion.
Yeah,
and
so
if we were to maintain that difference, then it would maintain that inertia and potentially just go on and on faster and faster and faster and faster and faster and faster. It's just never end.
If you did the opposite, would it just slow down then? What are your thoughts if you
basically we just you would essentially just stop. But remember, we're not in motion. So now you can see our friends how they now do their million miles an hour. And yes.
That's weird. I never thought about it backwards, because like now you could have something stop in a superposition almost, it feels like, right? Like freeze in time. That would be very weird.
Well, they would push up the inert if they would.
Yeah. Oh, you still there? Uh-oh. I think we might have lost Roy. So I think I'm just gonna riff real quick while we see if Roy can reconnect here. But oh, there you are. You're back. Can you hear me? Okay.
Yeah,
we lost you for a second.
I heard you all the way through there. I don't know what happened.
Oh, okay, good. Yeah, so just to reiterate that real quick, I think that, so if we think about the Alcubierre drive, if we think about contracting space in front of us and expanding it behind us, this is going to lead us to be able to achieve faster and faster, let's say, outside frames of reference speeds of whatever's happening there within the, let's call it craft or bubble or whatever. But then if we reverse it, then it's going to slow things down more and more and more and more until you potentially get to a point where you're frozen in time as if you were to approach the event horizon of a black hole, right?
Correct.
So there's a couple, that's a whole another aspect of it that I hadn't even considered, but I love the idea of symmetry and yin and yang, and, you can do the, opposite of things are always possible. So I appreciate the understanding there on that side of it. But now that you mentioned our friends, I think we're talking about the UAP phenomenon. I wanted to get your thoughts on some of that because I do have a lot of people and viewers who are interested in it. My personal opinion is that I think that there's life out there, probably everywhere is my personal belief. Whether or not there are beings visiting us isn't really that important in terms of my daily life, in terms of what happens to me. The technology is what's exciting, is that there's this whole branch of technology out there. I think that we're basically cavemen who just figured out how fire works. And then we're sitting there thinking, oh, we figured it all out. We've got fire, right? And it's like, well, you've got a long way to go still. So but I do find it still fascinating, the idea of non-human intelligence, what's going on out there. So go ahead and let me know what's your thoughts on it, what's your interest in the phenomenon, and anything else you want to discuss.
Well, seeing is believing, as they say, isn't it? It's all in the proof of the pudding. I was 13 years old. I was having a family barbecue with all my family on my 13th birthday. I'd been at the NAGC for quite a few years. By that time, I was dealing with quite heavy levels of physics already. What I saw, I pointed out, we live near Heathrow Airport, so I mentioned this in my video. I'm well used to seeing aircraft. I know exactly what an aircraft looks like. I know exactly where they stack, where they don't, where the helicopters come in, what trajectories and what routes and flight paths that everything uses. This thing essentially did not have the usual attributes of an aircraft, in that it had a permanent light source that was orange in color, orangey glowing red in color, that sort of pulsed more probably in a repeating pattern. So that caught my attention because it was different. Me being, instant, what are you mode, that sort of inquisitive kid. So I'm then asking the smart guy in my family, my Uncle Dennis, what's that, Uncle Dan? And he's saying, that's interesting. The usual sort of thing, won't put his finger on it. And then, more and more people's attention are being drawn to this thing as we're discussing it. And as we were, this thing left our atmosphere in under a second from a standstill position, above, about 40 foot above the skyline of the housing that was about half a mile away. So within 3 minutes, I said to myself, that's impossible, knowing the laws I know. The only way logical possible that can do that is this: it holds a relative faster rate of time. I'm 13, and I know already that they hold a fast relative rate of time. That started the pursuit of my understanding about what the attributes of time really were. In that enlightened me, that moment enlightened me, as it were. And then I started pursuing the attributes of time and looking for things in nature that would guide me in that way. And I found them in conservation and symmetry. So that then led to dilation theory. But it actually began when I was 13 years old on that evening.
Yeah, and it's tricky too, right? Time is because we're all on the same Earth, right? And we're on a surface and it's a sphere. So we are all theoretically experiencing time at a very, very similar rate, almost indistinguishable from one another. Right. So that's the trick of time dilation, why we don't see it. Now, for me, I wish I was only 13 years old when I had such an epiphany. It was actually, for me, it wasn't until I watched the movie Interstellar where I realized, like, wait a minute, what? Time dilation's real? And then I Google it because I didn't believe. I just thought there's no way. And so, it's been a rapid understanding for me on that front. Well, what are your thoughts then? Do you believe that there are other non-human intelligence beings visiting us? What's your favorite theory when it comes to non-human intelligence? Where do you think they're
Well,
from?
well, as we've explored it, the capability to be coming from absolutely anywhere in the cosmos is now, as this slaps Neil's ideas, who I'm talking about, right out of the park.
Oh yeah,
No,
yeah,
I mean, not a clue.
Neil deGrasse Tyson.
Yes. So
What a guess! What a guess! Yeah, I'm not a big
so
fan of his theories when it comes to non-human intelligence. I feel like it's a very closed-minded approach, right, to the science.
Well, classical physics, I'm afraid, tied to classical physics, must tied to to what he's produced all his career and his life, and he must stick to it. And I salute his stoic attitude to dead ideas.
Yeah. Yeah. So,
Okay.
and I guess what you're saying there is, and please correct me if I'm wrong, is that once you get to a point where you can have zero inertia and superluminal speeds, essentially quantum teleportation, but of macro scale objects, then the local frame of reference for the traveler, their time is, they're not going to experience as much time as it takes to, come here from 1,000 light years away. It's not going to feel like 1,000 years for them, right? They can come here basically instantly, right? So,
Well, you would. This is the thing. You would only need that very fast or relative rate of time if you had something you had to negate the gravity of.
yeah.
Okay, so if you're passing through a solar system, planets and things like that, turn on the phase. We need to be independent of these guys, or black holes or whatever. It would give you complete independence from everything. There would be no inertia upon you from anything. You're the fastest guy in town. Okay, right. So you only need that on, and the baggage that comes with that would be an incredible age, essentially, if you were to maintain that phase.
Yeah.
So that's the problem. There's a hang-up, aging. Okay, so you would rapidly age in that type of base state. In that, I mean, if I don't know, perhaps you don't age when you are the phase of quanta.
Yeah,
We
I guess
don't know.
yeah.
You see what I mean? There's lots and
Yeah.
lots and lots of things here that we need to test, look at what's going to happen, see what the outcomes are. There's lots and lots of things that need to be played with first before we even play with this. I do not recommend anybody playing with the phase of quanta in their whatever. Okay, Don't play with this stuff. Do not play with dynamic behavior in any way possible at all. It's extraordinarily dangerous. Okay. Your mum will be tidying you up with a mop. Okay.
Yeah. What do you think the implications are of this type of technology? I think that's probably a good thing to jump into next.
Well, we're going to have to face the implications of the technology. They are ontological.
Yeah.
Okay. Certain aspects of this are ontological. I won't go into that, now unless asked. But it's a tightrope. We're going to have to walk, like with anything, like with the gun, like with the bow, like with fire, like with the wheel, like with the aircraft, like with any development of humanity. We will have to deal with the implications of the change. Okay. Now, one of the changes is massive benefits to us as a resource, in that we are no longer limited to any resource. Why are we fighting? What about space? Well, we can go anywhere. What are we fighting for? Sorry, we've got bigger problems to deal with, and one of them is our dogmatic tribalism. It's got to end, folks, okay? Because if we go, we've got to go together. Okay? That's the rule. Okay? One rule that I figured out. That's the rule. You must go together. They will not put up with us being feral out there. Okay? End of. Now, if it is a construct, a holographic construct as such, what are nuclear fission doing? What is it doing? What are nuclear bombs doing? They're reversing the natural order process of the universe by ripping everything apart, rather than things getting more and more entropy and more complex. Okay? What's going to happen to the underlying quantum information there? Or the residing data, where that sits, or what it's related to? You don't know. Stop playing with this shit. Okay? That's the point. They have no idea what they're playing with at all. This changes everything, Ashton. Absolutely changes everything.
Agreed.
Would you, as a developer, if say you were responsible for this particular construct, let them piss with it like that?
No, from a database architect standpoint, you never want anyone meddling in your sandbox, so to speak.
You don't want anyone pissing with your baby.
Yeah, no, that's definitely true. What do you think? Just going back to the UAP phenomenon, real quick, of these UFOs we're seeing out there, I'm just going to call them what they are. What percentage would you think are potentially man-made at this point versus ones that are of other origin, unknown origin? And I think that this is more of a question of knowing how long this physics may have been out there. I mean, you're talking about it 30 years ago almost, right? Like, do you think that what would your thoughts be on the ratio there? And it doesn't have to be exact, just curious of your thoughts in general.
I think the morphology is the giveaway. Okay, the morphology tells you the actual levels of the technology. When you ultimately realize what it all is and how it all hangs together and everything, you realize that those conservational geometric symmetries essentially are at work there. And that if you can emulate quanta, perhaps we can emulate other forms of even smaller scale geometry. Okay, so that tells you your morphology.
So is that essentially saying that it depends on what they look like in terms of,
that tells you their technology, level. Now, I would say we were probably in the orb region.
Yeah.
Because that's probably the simplest thing to do. Okay. Or the sorcery sort of stuff. That's very easy to do. The cubes, that's very difficult to do. But once you get cube tech sort of level, then you can go city tech level, neutron star level. See what I mean?
Yeah.
It doesn't matter how big you get once you've got to that level. And this is what it's showing. This is confusing to me because I see the whatever, and I hear the reports of different. This craft looks like this craft looks like this. This has this morphology. This has that. And I'm thinking to myself, why are they in sources anyway? I mean, if you figured this stuff out and you know that it's dynamic, that emulation as such is the thing, then why would you even bother with the saucer basic stuff? Which tells me they haven't fully figured it all out, certain species. and that we might actually have to jump on quite a few.
Yeah. So I
Yeah,
think what you're saying there is the orbit sphere would be the easiest thing to make. So
yeah,
potentially, if we see spheres out there, that would be probably the lowest form of technology. That might be where we're at potentially if we're
yeah,
just hypothesizing, right? When you start to get
yeah.
more
We're just
complex
playing with it.
shapes, like that's where it's like, okay, now you're really able to manipulate the effects at the
Yes,
very small level, like very high levels of control of the
yes,
quantum effects, right? On the macro scale level. That's
yes,
interesting because it makes me think about Star Trek again. I was always going back to Star Trek for some reason with the Borg and their cubes, right? Even though it's not really how it would play out, but it's still it shows a level of just complete technological superiority, right? So,
yes. It does. But like I said, once you understand it, or it makes you want ponder, like, did they miss a trick? You know,
yeah.
it's like, or is that the cheap budget version?
Well,
You
that's what
know,
I
it's
I think
like,
about the video game Civilization a lot. And the part about it I think of is there's this tech tree. And like generally what happens is different people get different parts down the tech tree. And what this kind of is analogous to is this idea that just because a civilization is very advanced in one area doesn't mean they're going to be very advanced in all areas, right? And you could also look at our past civilizations on this planet. And I think you could argue some of that as well, is that some past civilizations may not have had computers, but they still understand these quantum effects at a level maybe even better than we do right now. And so I find that stuff very interesting as well, is that that could explain why you might have beings that are visiting us in a saucer, even though it may not be the most efficient method of, a macroscopic quantum, entanglement or quantum coherence, but it's still a method where they can still, achieve whatever they're trying to do to travel whatever distances they need to travel. Maybe they're only coming from Alpha Centauri, and that's satisfactory. I don't know. I'm just making it up.
they could be coming from even nearer. They could be coming from, say, Europa,
Yeah,
or
there you go. Yeah, even within
or
the
or,
solar
or
system itself,
yeah, or some, I mean,
or here.
these, it's really, yeah, or even here. Who knows? I mean, best guess, isn't it? Really, until
Yeah,
we actually get, and ask them, "Hi, where you from, chaps?"
yeah.
It's that sort of stuff. But it's like, what was I going to say? Yeah, I mean, those rules of properties to denote the behavior don't just work for the cosmos. They seem to apply everything,
Hmm.
even in nature. So if we look at the attributes of them, large eyes,
Mhm.
small, it sounds like a subterranean species to me.
Hmm.
Properties denote, you see what I mean? The environments, as it were. And the environments denote the attributes of whatever it is. Okay, so if we look at them and then look at, okay, what are the environmental things upon them? Then we can pretty much say what sort of where they're from, and that sort of stuff. I mean, I think Gary Nolan should be digging down that one, really, rather than me. But it seems pretty obvious to me. Huge eyes, well, they live in a low light environment. You know what I mean?
No, yeah.
What they
That's not just
do, yes,
evolution. I
space.
mean, right? I mean, it's the idea that you
Yes,
adapt to your environment, especially
exactly.
over long periods of time. I mean, we can see
Yes,
that even
but
here.
however, we've now got another problem. It comes up to another issue, which is that, say they were using that phase all the way,
Hmm.
and that things rapidly age within that phase state unless you've actually mastered DNA replication process,
Sure.
where your rate of time is no longer relevant to you
Yeah.
and you will live forever,
Yeah.
like an octopi or whatever, like some jellyfishes can do,
Hmm.
that sort of thing. Um, or would you make them en route or when they arrive?
Yeah.
Some of the attributes of this require that, I think, to some degree, that you require sentience.
Mm.
Okay, now, yeah, consciousness is linked in here. A whole woo crowd out there are going to be raising their arms in the air. We love you. Okay, but yeah, it does. Okay, in that everything of that moment denotes the outcome, even what you're thinking. Okay,
Mm.
all that sort of stuff, your consciousness. Now, as I said before, if we deal with the universe in the way of contextualities, then one could consider consciousness itself perhaps an emergent property.
Mm.
And that
Yeah.
we are, therefore, if it's a holographic construct, as the hypothesis is looking like it is, then you are Avatar.
I was about to say that.
Okay. So now we are all linked in that parental domain, as it were, and we are all here as avatar
Yeah, it's like
in the abstract.
your consciousness
Yeah.
out here, right? And
Yes.
that's in
Somewhere.
the
Somewhere
matrix
out there.
somewhere else in the underlying framework, and this is our
Yeah. We
physical
we
body
can't
that
ever
we're
touch it as
connecting
such.
to it, right?
Yeah, because we do not hold the correct context.
Mm,
Now
interesting.
his developer head's turned on that one. See what I mean? It's all about one's contextuality and one's properties at any one moment.
So what you're saying
And
there
that
is
we,
that you could fly your object to another distant solar system without even maybe passengers in it. You can build the body when you arrive and have your consciousness somehow avatar your way into it, right? And now
yeah,
so there might even be ways to get around this issue of your speeding up of your time, kind of causing this mass aging, rapid aging to
yes,
happen to you. Hmm.
yes. There are multiple opportunities now. You see what I mean? One
Hmm.
thing leads to another, it leaves more opportunities. But
Interesting.
you've got to have a total grasp of the whole big picture, really, before you can even start to look at some of those probabilities or possibilities.
Yeah.
I mean, you were talking about Borg. In all of the probabilities or possibilities, could there be Borg?
Yeah.
No. That's the answer to that one. No. Because once you realize, as I said, what the cosmos is essentially, and they will get to that point, no matter who you are or where you are in
Yeah.
it, okay, then you will understand fundamentally a lot more about it in what it is and what its purpose, therefore, is,
Hmm.
and what your purpose within it is, in that it is of you and you are ultimately of it.
Hmm. So you're saying that there would be a higher spiritual understanding as to more of a mechanical, yeah,
Much more so, incredibly more so. Okay, that's more sentient species of that perception level of perception would consider everything holy,
yeah, spiritual.
everything.
That's interesting. It makes me think of the idea of dharma and holding life to be sacred, like the way that people in India hold cows to be sacred, etc. It's like
Yes.
you achieve this unity with the planet itself, and I think that's a very beautiful thought in general.
Well,
And just
unity with the cosmos, essentially.
mm,
That's the point. You would reach that point. Now, like I said, some of the bits and pieces are ontological, but
mm,
some of it is ontological to the point of it's actually bloody good news for a lot of
yeah,
people.
yeah, it really
Okay.
is.
Now, I've been an atheist my whole life. My head has been filled with physics and science and everything else. Ask anyone in my family what I'd be saying about God forever. Okay. So I'm not going to hold my hands up and say that I believe in God, but any construct requires a constructor.
Yeah.
That's the point. Any construct requires a constructor. And we do live in a construct. We
Mm,
live in a contextual, emergent, contextual duality of
mm,
geometric symmetries within symmetries projected upon a gauge lattice as a holographic space-time continuum. That is the cosmos.
mm.
Now we know what the box is. It's time to play.
Yeah, so on that front, and this is, I think, one of the last questions I want to ask, although it's going to bring it back to the dark side of this as well, is what do you believe that this type of technology, I'll just throw this out there. My understanding is that this is like a Pandora's box. Once you open up the
Yes.
world of this technology, it's not coming back in. You're getting all of it. You can't just pick and choose. This isn't Burger King. You can't customize it, have it your way. You've got to take everything. And what that means in my mind is doomsday weapons, the ability to destroy our whole planet becomes just simple, not just a matter of dropping a bomb, but like literally destroying the whole planet or destroying the sun or maybe even destroying our whole universe. What is your thoughts on that? And how do you think humanity has to be responsible to prevent that from happening?
Exactly that. We need to be very, very, very responsible. Okay.
Mm,
Now, we already have that capability. We already harness antimatter. If we were to allow that antimatter to collide, as it were, to nothing, that
mm.
would remove our planet and half the solar system. So we already have that capability without this technology to do that.
And real quick, what is antimatter?
Basically, it's the other side of matter,
And how do we
essentially.
have that?
The
Just because
other
I think that a
side
lot
of
of people
that.
would argue that we don't. So I'm just curious.
Yes, we do have it. We have anti-hydrogen, for example, and we use it at CERN. Okay,
Okay.
so we do hold it. But we only produce very, very small micro
Mm,
amounts of it at a time and then release that and observe that. So
got
it's
it.
tiny, tiny, tiny amounts that we're actually producing. But we do. So the capability of doing what you say is already there. Okay, but
Mm,
we haven't done it. Why? Because everyone loves their children.
yeah.
Okay, everyone wants a better world for their children, even the Russians. Okay, even the Chinese, they want a better world for theirs, and so on and so on. And if we can come to a common agreement that, okay, let's live for our children and do this for them
Mhm.
and for the future, and I think we're all going to be in a good place. Okay, and that if we set down some ground rules, for example, no militarization of this technology, none. Okay, this technology can be mitigated when one understands it completely, Ashton. I'm not going to go into those details,
Sure.
but it can be mitigated.
Okay.
We can stop them. Okay, we can control them if we wanted to, with a
Mm,
greater understanding of the technology. Okay, so that mitigates all that. Oh, we're going to blow up the world with this, and we can zoom things into things like that can zip through matter exactly in that funny state and everything. Well, yeah and no, because you can mitigate against this technology as well,
hmm.
just as much as you can create it.
That's good to know
Okay,
or
so
interesting to know. I mean, one thing too,
yeah,
Dave
there's
Rossi
that.
has mentioned is this ability to detect gravitational waves, which could be a way where you could detect the use of this technology, anywhere
Yes,
on the
it is.
planet and jump
Well,
in like
what is a
the.
gravitational wave? Now,
Mm,
if we look at the dilation theory side of it, what is a gravitational wave? All that is essentially a ripple of slowed time in the symmetry of time.
mhm.
Okay. So all you need to do is look for where, and what our friends are doing is that they are doing the other end of that. They're not slowing time, they are speeding up time.
Yeah.
So all we need to do is use interferometry in an array and see where time
Time
is
is
being
speeding
sped
up.
up.
Yep. And
Okay.
then.
We
Mm,
can do that now. So we can use these things to track them or put up safeguards against them or whatever. Also, any this obviously when it
mm,
produces into a phase state is another form of simply electromagnetism. Anyway, doesn't matter. It still is the form of electromagnetism. Diamagnetics reject electromagnetism.
mm,
Okay, so diagnetics can be a shield against them.
mm,
Okay. Also, the properties of diagnetics can help us create that state in that if you were to have a close form of energy associated next to a diamagnetic and you were to put power to it, the electrons traveling through that medium would be rejected by the diamagnetic and become extended.
mm,
Extended electrons are a property of quanta.
mm. So it can
See
act
what I
as a
mean? It's not
shield, and it
this
can also act as potentially
exactly.
a
Well,
building tool, building block for something.
yes, yes, where you
Mm,
can create it or reject it, as it were, using exactly the same material.
mm,
Okay, so it's extraordinarily easy to make this stuff, to be honest. And the technology is essentially the same as your refrigerator, in that all you are doing is that you are getting preferential outcomes of behavior by changing one's potential properties,
mm.
which is exactly what we do in a refrigerator.
Yeah. One of the most powerful diamagnetic elements is bismuth as well. I think the one keeps coming
Yes.
back up time and time and time again in this phenomenon
Well, liquid,
discussions.
liquid bismuth is 500-fold, by the way,
Really?
than its solid property. So again, those symmetries, different things in different symmetries give different relative rates of time and give different strengths of its electromagnetic resonance ability.
Hmm. So melting
Because
it down might be a method that you could do to change its properties then.
yeah, well, heat it up. Its
Yeah.
its melting point is very low. It's even lower than lead.
Hmm. Interesting.
So you could have
Cook it on
something
your
like
stove.
yeah, so liquid form of bismuth, um, and then have something with high linear, say strontium with high electrons, so that the closer the electron is to the nuclei, the harder they are to knock off to extend. Okay, the
Got it.
further they are away from the nuclei center, the easier they are to knock off to extend.
Hmm.
Okay, so you want materials that got those high electrons. So strontium is a good one, boron, things like that.
Hmm.
And then have that behind some sort of diamagnetic. pump some power through it, say even copper or magnesium, something that something really cool that can you put round in those particular shapes that you need, as we see in the aircraft, the particular orbits of the electrons, as it were. So yeah, that goes back to your flight in that basically what that's showing is a transitional phase in that the orbs are emulating the behavior of quanta because they already hold that superconductive state and are already considered by the universe, therefore quanta. Right. Okay, so it gets into a pattern. Oh, we've got nuclei, we've now got electrons orbiting. Oh, quanta, transitional phase. Okay, that incredible speed rate of time instantly, the cold environment and so on. It looks like teleportation, but essentially what this thing has just done is shot off an incredible rate of speed that way, faster than your eye or the camera can see. So yeah, you'd only have to need it on for like a second and you'd be 300, 400, 500 miles away that way.
Yeah, that's awesome. Yeah, and just for people not following along, we're talking about the MH370 videos. We're talking about the orbs traversing around the plane and the plane just disappearing straight from space-time with this endothermic event, this absorption of energy that we see there. I think that a lot of people have their own opinions in terms of how to explain it, and that's part of what is so exciting for me when I talk to physicists and engineers is getting everyone's different theories and understandings of how it's happening and trying in my own mind to like mesh and reconcile them together. So, I think that's
the
probably
neutron star. Essentially, the neutron star article. Look at the other one, the correlation with the spin and the time and its rates and so on. And pretty much you don't need a degree, just like I said, common sense, really. Awesome. Look at what you're looking at, examine that. What are the properties of it? What does that correlate to? Do we know anything about that? Yes. Does it then make sense? Yes. Gives you the answer.
Awesome. Well, thanks, Roy. I think that's probably a good spot to end on this particular conversation. Do you want to go ahead and plug anything or anyone or, thank anyone or whatever you want to do? I'll give you a few moments. Go ahead.
Well, obviously, I'd like to thank my gifted colleague, Martin Gibson, who it goes under the account of Uniservant, where dilation theory in the math and all of the detail and all of that, the physics side of it, the more serious side of it, rather than my abstract musings, as it were, is on his account. The more visual side of it is on my account. And also, I'd like to say that for any technical reference or anything to do with the phenomena, people should be contacting Ted Rowe. Okay, because Ted is fully aware of the modus, the abstract, and is one of the people that's actually seen the non-public domain information. Okay, so if you do want any, I will plug Ted. He's God mode without UAP. Okay, any subject. Okay, and Ashton, keep digging. I know that you're right, and I thank you very much for your video, because your video, when it was brought to my attention, proved dynamic behaviorism is correct. So thank you.
Yeah, no need to thank me. It's the world's videos, to be honest with you. And I hope that those videos end up bringing a greater truth and understanding of science to the entire world. That's really my only objective out here, is spread the truth.
I'm free. Anybody wants to ask me questions, just send me down on X or Twitter or whatever it is you want to call me. I jump into rooms often and answer people's questions as well. So I'm always accessible. And like I say, it's been a long time shouting at doors, but they're opening.
Yeah. So is that the best way to find you on Twitter, on social media?
Yes, it really is. I don't use any other form of social media. I think a few people created a few things for me, but I never visit them at all. I'm usually on here because majority of all my colleagues and so on, we communicate through this.
Yeah, so you can be found at Roy D. Herbert on Twitter. So go ahead and give Roy a follow out there. He's got several thousand followers already. And as he mentioned, he's got some pretty prominent physicists who follow him as well. So if you want to be on the cutting edge of science, this is the man to follow right here. Okay, guys. Well, we're going to go ahead and close down Hard Truths number 5. Thank you all for watching today. We appreciate it. And thank you, Roy D. Herbert, very much, theoretical physicist, for being here and teaching us about time dilation and dilation theory.